Coming to focus in a second. Some things we should know from previous lessons is that there's such thing as a factorial. So 7 factorial is, the exclamation point, 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, 7 factorial is something we came across the last day. In general, that's, in general terms, anything factorial will be the first itself multiplied by 1 less than itself, multiplied by 2 less than itself, and so on until you reach 1 again. Okay, and that was the factorial notation we were talking about on Friday. And this led into this NCR. Written like this, NCR sometimes, and this had a formula, n factorial and n minus r factorial multiplied by r factorial, which seemed very complicated indeed, but luckily enough we had a calculator button that would get that for us. So towards the end we did one example of that. We remembered it was 5 NCR3, so 5 C3 it'll be called. Let's do that example out again. So that would be 5 factorial on top of this fraction, all over n minus r. So that'd be 5 minus 3 factorial and 3 factorial. Now, let's do a little expansion of that over here. 5 factorial on top is 5 times 4 times 3 times 2 times 1. 5 minus 3 is 2 factorial. So that's 2 factorial, not. So we just rewrite as 2 factorial. And that's 2 times 1. And that's multiplied by 3 factorial. 3 times 2 times 1. Some of this will cancel. 3 times 2 times 1, above and below, cancel each other out. 2 fits into 4 twice. So we're left with 5 times 2 on top, which is 10. Okay, now hopefully all your calculators are working, and this can also be done on the calculator. So we rarely use this formula actually, but we usually just take out our calculator and just okay. So if you want to do it on a calculator, you will press 5 because it's going to be 5 and then the application. So go to math, go over here to probability, and it's the third one down. Press enter. 3. So 5 NCR3. It's this. And you get 10 as well, which is the same as we got over here. Now we briefly related that to the binomial theorem. But we'll come back to that in a second. How does that all link? And it's something to do with that coefficient of the binomial expansion. Okay, so we'll come back to this in a second when we're looking at the general term. An example of binomial theorem, just in case you've forgotten. Let's look at a general one. So a plus b to the power of 5. If you want, you can always solve this by actually multiplying out a plus b 5 times and gathering all the like terms. And that'll be quite difficult because you've got to go a times that and then b times that, and then you got to do whatever answer you got that and multiply it by that, and whatever answer you get there you multiply it by there, and whatever answer you get there, you see, keep doing it. Whereas we found there is lots of patterns that will get us to this position. Okay, so we can notice all sorts of things about this pattern. The main things are probably that the a power, the first one in the expansion, is just going down one each time. 5, then 4, then 3, then 2, then 1, then nothing. And the b power is increasing from nothing, 1, 2, 3, 4, 5. The coefficients then were from Pascal's triangle. Now, if you remember Pascal's triangle, I can draw a little sketch of it here. Oh, not 2. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And that was Pascal's triangle, and we saw the patterns in there. If you want to get the next line, you just add 3 plus 3 to get 6. 3 plus 1 to get 4, and 1 plus 3 to get the other 4. And then 1 plus 4 gives 5, 4 plus 6 gives 10, 4 plus 6 gives 10. Okay, so it worked like that. And there's 1 on the outside. Okay, and that was our coefficients here. All right. Okay, so we needed to link all that, and now I don't know if anyone actually managed to do the general term in the homework. You could have done the other questions without knowing how to do the general term, but let's talk about that general term now. Perhaps some of you did some research and just look back at the examples that are in the book, but we'll get there. The general term is the formula for it, and you'll find this in the book, is okay. Ooh. And this is to find a particular term in an expansion. Well, that looks pretty nasty. So we need to translate this into what we know so far. So that's the general term of a binomial. What we know. So let's use this and let's see what we can apply to the examples that we know from before. So this one above. Okay, let's just look at the end first. B to the power of or. Now, the first term, there's no power of b. The second term, it's b to the power of 1, I suppose I can put in here. B to the power of 2, b to the power of 3, b to the power of 4, b to the power of 5. So let's just say, look at this fourth term. So that or would be 4. So that or would be 4, which means this or would be 4, which means this or would be 4. But what term number is that in our sequence? Remember, so this is the first, second, third, fourth, fifth term. So six terms in it. So this one, or is 4 on the fifth term. Or is 3 in the fourth term, or is 2 in the third term, or is 1. So it's 1 behind. And that's why this is the t or plus 1 term, not just the t or term, because the or is 1 behind here. Hopefully that makes a small bit of sense. So if I want to find T5, that's actually the T4 plus 1 term. So or would be 4. So if I want to find T5, term 5, that's this one here. If I want to find term 5, let's just leave this weird looking bracket at the front blank for a second. A and B, I know that B is going to be 4, 1 less, because it's the or plus 1. 4 plus 1 gives 5, so B is 1. Okay. Now, I know it's n minus 4, so that's have to be 4 as well. And this, perhaps, can help find what n would be. It's something minus 4, but we already kind of know the answer. The answer needs to be 1, so it has to be 5 minus 4. So n is actually the power. So anywhere there's n, I'm going to put 5. Anywhere there's or, I'm going to put 4. This general term, we'll be able to use it a little bit quicker as we go along. We'll do a more specific example in a second. This general term can help us find any term in the sequence without having to do out the whole thing, or even logically figure it out. So on Friday, what we tried to do is logically figure it out without knowing this general term. And that's why that's what you should have done for homework. If you didn't do it, that's fine, because it's difficult to logic it out. It's far easier if you know this general term expression. All right, so I haven't finished yet. The fifth term in this sequence is going to be then, I'm just going to write, I'll put it on the next page actually, because I'm running out of space. The fifth term of this sequence is going to be, I'm still kind of semi-ignoring this bracket thing, and I'll come back to that in a second. So I'm just going to write 5, 4 like that. And then it's a to the 5 minus 4, which is 1, and b to the 4, which is 4. So I can write in the 1. Okay, so we're pretty close. Now I know my answer is 5 to this brackety thing. This brackety thing is 5. What is that brackety thing? Well, that is another way of writing 5NCR 4. 5 choose 4. It's got to do with the factorials. It's a more mathematical way of writing this. So let's see on our calculator. I'm just going to copy and paste that one down and change the 3 to a 4. And hopefully it gives me a 5. It does. 5 choose NCR 4. All right. And that's that factorial thing that's basically finding Pascal's triangle. It's finding it's actually the 5th number, not the 4th number, because it's 4 plus 1 gives me the 5th number. Anyway, so that's it in general. Let's look at it more applied to a specific example, like you'd be asked and like you were asked for your homework. So now we can get it quicker without having to do it all out or logic it out. Okay. The 7th, let's find the 7th term of 3x minus 4 over x squared to the 14. Okay. Let's find that 7th term of this. Okay. So now we are equipped with this formula. We can start to use it now. This general term. Okay. So the 7th term, maybe we can type in the chat, what's or going to be in the 7th term? Laura thinks it's 6. Riley thinks it's 6. Yeah, it's going to be, because, yeah, this has got to be make 7, so 6 plus 1. Okay. All right, so or is 6, so T7 gives, that's 6. And n then will be always this power here. So it's going to be 14 and 6. A then is going to be 14 minus 6. And b then is just going to be 6. So remember we did discuss this, that a to the power of 8 then and b to the power of 6. So 14 take away 6. These two have to add 14. And that's what we did on Friday. We logicked this out. We didn't use this formula. But anyway. So we have 14, choose 6, a to the 8, b to the 6. Now, in this particular case, we do not have a and b anymore. This question is using 3x and minus 4 over x squared. Okay. first things, we're going to replace things. So 14 choose 6. Just once again, this is the quick way. Just press enter on the previous one and you can change the numbers. Oh no, it doesn't change it to 2 digits. I forgot that. Got to do it again. Math. Probability. There we go. 14 choose 6 is going to be quite a large number. 3003. Because think of that. That's going to be 14 rows of Pascal's triangle down. That's quite a large number. So 3003 goes instead of 14 choose 6. A has been replaced by, well, that's A and that's B. So A is no longer A, it is 3x to the power of 8. And B is minus 4 over x squared to the power of 6. Okay, let's simplify that. Sorry, it's a bit out of focus, I can see that, but it'll come good. Okay, so let's simplify that. We have the use of the calculator, but maybe we'll just look at the powers here. I think x to the power of 8 and x squared to the power of 6, that's going to be x to the power of, if we just do a bit of work, it's going to be x to the 8 on top and x to the 12 on the bottom. And that's going to be, well, if you subtract 8 minus 12, it's x to the minus 4, isn't it? Using our knowledge of indices. So x to the minus 4. And you can just do 3 to the power of 8. Oh, and times 4. Well, that's going to be horrible. And there's 3 to the power of 8. It's a huge number. I'm doing that off screen. 6561. Okay, I won't go into it because this is too large a number. It probably, if this was the question that asked you not to simplify, but it's times 6561. That's 8. 3 to the power of 8. Negative 4 to the power of 6 is going to be a huge number as well. Oh, my calculator. Just do 4 to the power of 6. It's going to be positive, so it's times 4096. Oh, geez, it's going to be huge. And then x to the negative 4 at the end here. Okay, and you can multiply them out, and that would be your coefficient. An absolutely gigantic number. Okay, and that is how you use the general term to find any term in a binomial expansion. So now let's look at your homework using this easier method than you guys would have had to do, or maybe you use this method, some of you. Okay, so where's your homework? Okay, so question 4a from the homework. Write down the general term of this expansion. So the x plus 2 to the power of 8. So the general term now should be maybe a lot easier. If you'd done the research, maybe you'd figured this out already. So t to the r plus 1 would be our general term. General term in this case, there's 8 terms. Choose or, we don't know which one we're looking for. A is going to be x to the power of 8 minus or, and then b is going to be 2 to the power of or. So that's how you would set up a general term for this one. Okay. Generally, this is not asked because this is going nowhere. You're more than likely going to be asked for the specific question, like in part B, find the coefficient of x to the 5. Now, x to the 5, what I wanted you to do for homework was to figure this out using descending powers. So the first one would be 8x to the 8, and then so on, and figure out what 2 to the power of would have been. Now, maybe that was a bit challenging, but it should be a lot easier now. So x to the 5, which term is that going to be in the sequence? So this would have to make 5. Or needs to be 3. Doesn't it? Hopefully. So it'd be 8, choose 3. X to the 8, take away 3, which will give 5. And 2 to the power of 3. So I've made or 3 because 8 take away 3 will give me x to the 5, and that's what I want. From then on, what you guys would have done if you didn't have the general term is just use your Pascal's triangle to find what that one would have been. You can go 8 rows, that's not that difficult. But so 8 choose, now that we have 8 NCR, math, go across CR 3, 56, 56, x to the 5. Now it's not, because we need to multiply it by 2 to the power 3, which is 8. So it's 56 times 8. And gives me 448 x to the 5. And that is the x to the 5 term. Now that's going to be right in the middle of that expansion. But now that we're armed with this, we should be able to find any term in that expansion. Okay, we'll keep going. Question 5. The general term is just the same as the one above, it's just with ors in it. We're going to kind of use it in a second, so I'm just going to go straight to the question. Find b given the coefficient of x to the 4. So here's my binomial. So binomial, once again, 2 terms, bi, and to the power of something. Find b given that the coefficient of x4, so we know what x4 answer is, the coefficient is, but we have to work back from that. Okay, so this is the x4 term. That is the x4 term. Okay, let's use our general formula to create something that will be equivalent to that. So if it's a 7, 7 goes here in n. I'll just leave that blank for a second. X needs to be to the 4, so that's going to be 7 take away something to make 4. I think it's going to be 3 again, isn't it? And that's going to be b to the power of something. Remember, so if I have to make x to the 4, it has to be 7 take away 3 to make x to the 4. So if that's 3, that's 3, that's 3. Now it's a calculator job to find, or you can use Pascal's triangle. The 7th row of Pascal's triangle is not too bad. It's about getting the right one. It's the 35 one. So 35, 7 choose 3, 7 NCR 3 is 35 on our calculators. I know that's x to the 4, 7 minus 3, which is what I want. B to the 3, well that's still just b to the 3. Now I know that equals minus 280 x to the 4. Now it's an algebra problem. How do I isolate b cubed? Anyone get an answer for this? Perhaps you can type it in the chat. Minus 2. Okay. Okay, well, I want to isolate this b cubed. So I think if you divide both sides by x to the 4, it will cancel. And then divide both sides by 35. That fits into that once, and I'm left with 280, or negative 280, divided by 35, which is 8. So negative 8, if it's negative. And that equals b cubed. Oh, so if b cubed is negative 8, yes, b must be negative 2. Nice work, ready? All right, so that was question 4 and 5. Let's look at, I'm not going to do all of question 6, but I'll do maybe the second one. Find the constant term of the expansion. Okay, so this is question 6b I'm going to do. Find the constant term. Of this expansion, x minus x squared to the power of 9. Oh, jeez. Anyone turn on the microphone or type in the chat what did it mean by the constant term? someone must know what constant term is. I know it's Monday morning, but... Wow, only I know what a constant term is. So, only contains a number. Thank you, Georgina. Someone helped me out. I wasn't sure what it was myself. Yeah, it's not affected by the variable, so it's not going to change throughout. So, if for a simple example, perhaps you would, when you're dealing with sequences theories, and you got the nth term, you got 3x. Oh, sorry, n is the nth. 3x plus 1, or 3n plus 1. This plus 1 is the constant term. It doesn't change. It will always be adding 1 forever and ever, no matter what the term is. So it's a constant. It's not affected by a variable, which varies depending on which term it is in the sequence. So the constant term in this case cannot have any x's with it. And how am I going to find this? I think we did an example like this on Friday without actually stating that it was a constant term that we had found. Oh no, we hadn't. So sorry, no. But it was a similar kind of pattern. It was where the x's. Where's that other sheet? Kind of started to meet in the middle. A bit like this, where we have. If we have a state where x to the 8 and divided by x to the 8, instead of 12 in this case, we'd be left with x to the 0, which of course is 1. So when we have these fraction type ones, where 1 is an x above in the numerator and 1 is an x in the denominator, eventually they'll make a constant term somewhere in the middle of the expansion and not just at the end. Usually in an expansion, of course, if we've x plus 1 to the power of 10, I know that the last term is going to be 1. That's the constant. But if you got an expansion like this one, the last term won't be a constant because that's going to be x to the 28. So that's not constant. But somewhere in the middle, we can find a constant. Now we need to find that somewhere in the middle in this case. So somewhere in the middle. Does anyone know which term we might be looking at? So we can look at the general term. Now that we have that as part of our weapons, we can use that. Or it's a real logic type question. It's x, it's going to be x. This one's going to be to the power of something. And the minus 3 over x squared is also going to be the power of something. But if we think about it, this one needs to be twice the power of this one. So that they cancel out. So what's the power going to need to be? So we can put in or and n minus or. I know that n is going to be 9 anyway. So it's going to be 9 take away something. That's what we need to find. What is the or? What is the takeaway? What is the power? Anyone know what that or should be? In order for this one to be double that one. Okay. Well, let's test. Okay, let's have a guess. Maybe it's 4. Okay. So maybe it is the fourth, not the fourth term. Maybe the fifth term. Maybe it's the fifth one. Okay, maybe. Let's see what that works out as. 9 choose 4. We won't do that now in the calculator. We won't think about that. We'll just look at the x powers. That's x to the 9 take away 4, which is 5. And that's going to be minus 3 over x to the 4. Okay. That's going to be x to the 8, isn't it? X squared. So that's going to be x to the 5 divided by, with a little, this is rough work over here, x to the 8. If I were to expand this out, I'm going to get x squared, x squared, x squared. So it's x to the 8. And if I take away those powers, that's not going to work. 5 minus 8 is going to give negative 3. And that is not going to work. So this is wrong. Okay, so that's the first attempt. All right, second attempt. I know there's going to be, it's the power of 9, so it's going to be, start with x to the 9, and then it's going to be minus something. And this one's going to come up. Does anyone have a guess what or might be? What this number needs to be? 3, possibly. Let's try 3. Okay, so let's leave the 9 and 3 on here. We'll do that if needs be. X to 9 take away 3 is going to give 6. And then this one is going to be, well, I'll actually multiply this out. Minus 3 cubed is negative 27. And x squared cubed is x to the 6. And what happens? X to the 6. So if we multiply this, you're dividing by x to the 6 and you're multiplying by x to the 6. They're going to cancel out, or you can do the equals 0 over here. And there we go. We have a constant term in the middle. Okay. Now finding the coefficient. Now that we have this thing, we don't need to use Pascal's triangle anymore, so we can just go straight to our newly found NCR button. So I just took the one down from before, changed that to a 9. And I have 84, 9 NCR3. So that's 84 times negative 27, and that will give me the coefficient. Negative 2268 is the coefficient. If you got that, well, that's really good. This is very difficult homework. Okay, so that's 6B done, finding the constant term. All right. I've done a lot of maths. I'm not going to set you any extra homework for tomorrow's class. Tomorrow, I need to check. Do we have you tomorrow, or is it the next day? It's the next day, Wednesday. So, but I'd like you to re-go over, so page 24. Remember, it's the book 2, not book 1. The one with the black cover. Page 24. Questions 4 up to 7. So I've done some of them. I didn't do any from question 7, so you should be able to have a go at question 7. Once again, it's pretty tricky. This is tricky stuff. If you found that this was easy, maybe try 1 or 2 more from, so I'm going to give you 2 options. If you found it was easy, maybe try questions 9 and questions 10. If this was difficult and you're not entirely sure, go back and do question 1 and question 2. So try and do question 4 to 7 again. And if they're now easy and you're getting the hang of them, go on and do 9 and 10. If they're not easy, don't worry, we're going to spend the next couple of lessons going over this. Binomial theorem is a difficult topic, and it's it's hard to simplify beyond how much we've done. But by the end of the week, we should have it down.